Good evening and welcome to the Zeiss Planetarium here in Berlin, part of the Stiftung Planetarium Berlin. I'm Anna Green, and today I am going to be doing our Starry Night program for you directly from the planetarium. Helping me today with the technical support is Stefan Gotthold, and flying for me will be our director, Tim Florian Horn. And we are all, as you can see, this is an empty room. We are all adequately socially distanced and staying safe, and we are hoping that you are staying at home safe. And thank you for inviting us into your home this evening so that we can share the wonder of the cosmos with you. So normally we would, of course, use the projector that you're seeing behind me right now. Unfortunately, we won't be able to share that part with you. Perhaps you've seen that if you've been here before, but never you fear, we are still going to see some pretty amazing things tonight. So with that, I'm not going to blather on anymore. Let's go ahead and start with a beautiful sunset. All right, so here we see an absolutely beautiful, beautiful starry sky, and probably in a way that most of us, at least most of us who live in the city, have never seen it before. We certainly don't see the stars like this here in Berlin. Berlin suffers, of course, from light pollution, like most major cities do. But were we to shut off all the lights here in Berlin, or to go a little ways out into Brandenburg, which is the darkest area of Germany, we would be able to see the stars as beautifully as we see them here. So what we're looking at is our sky this evening, and I'm going to start with a favorite pattern of stars of most people, one that most people are able to find on their own, and that is the Big Dipper. Or at least that's what we call it in the United States. Now, in England, for those who learned British English, that is known as the Great Plough. Here in Germany, it's the large cart, and in France, it's the large casserole dish, or la casserole, saucepan. So the Big Dipper is not a constellation, which many of us learned in school. It's actually what we call an asterism. And an asterism is just an informal, quote-unquote unofficial group or pattern of stars. Now, how is that different from constellations? It's not that much difference. The big difference is that the IAU, the International Astronomical Union, they're the ones who make the rules for astronomy. They have set 88 constellations that they have dubbed official. And so those are what we call constellations. Anything else is an asterism. What that means is you can make up your own asterisms, as many as you like. But as with the case of the Big Dipper, many asterisms are also very well known. So the Big Dipper is part of an official constellation, however. It is part of the constellation known as Ursa Major, the Great Bear. And Ursa Major, or our Big Dipper, are going to help us with finding north. So if you're like me and you're what I like to refer to as being directionally challenged, in other words, you have no idea if you're going north, south, east, or west, this can help you with finding your bearing. No pun intended with the bear. So what you're going to do is you're going to use the front two stars of the bowl of the Big Dipper, Merak and Dubhe. They will guide the way. So if you take the distance between them, you can draw it out 5 times, and that will lead you to our North Star, Polaris. And the cool thing about the North Star is that it is always in the same place as long as you stay at the same latitude. So what that means is as long as I stay here in Berlin, it doesn't matter the time of night or what season it is, that North Star will always be in the same place. And that's what makes it so reliable for finding north and being able to get our bearing. Now, the North Star is the very tip of the handle of the Little Dipper. And that's how you can always remember that the Little Dipper will always be in the north since it's attached to the North Star. And if the Big Dipper is part of Ursa Major, the Big Bear, then of course the Little Dipper is part of Ursa Minor, the Little Bear. Now, these constellations are what we refer to as being circumpolar. And the reason they're called circumpolar is simply because they seem to circle the North Star, the pole star. And this means that we are able to see them all throughout the year. They'll always be there. But we also have what we refer to as seasonal constellations. And we are currently in the season of spring. It doesn't become summer until the middle of next month. So we're going to be focusing on the constellations and asterisms of our springtime sky so that you can enjoy those for the next month before summer starts taking over the sky. And we are going to start with one of the first springtime constellations that appeared, and that is Leo the Lion. And to find Leo, you can use the back 2 stars of the bowl of the Big Dipper to draw a line down, and there is Leo. Leo's often recognized because the head and the mane look like a backwards question mark of stars. And Leo comes out right around the beginning of March. And so if you've ever heard the old phrase, March comes in like a lion, that's because of Leo the Lion. March comes in with and like Leo the Lion. Now, our next star that we're going to look for, we're going to use our Big Dipper again. It's really our guide to the springtime sky. So we're going to use the handle of the Big Dipper this time. And we're going to see that it kind of curves or arcs. And that helps us remember that we want to arc to Arcturus, which is the star that we just went to. And that is part of Boötes, the herdsman. Now, Boötes is another one of those patterns of stars that, or constellations that sometimes has a different name depending on the culture. So in the United States, we call him the herdsman, and we talk about him guarding over the cattle from the sky. Here in Germany, he is the guardian of the bears, and he guards the bears in the sky. Now, being that he's a herdsman, or in England, he's a plowman, or the bear keeper, he would need some help with that. And so he does have his hunting dogs, Canis venatici. And you'll see that Canis venatici, they're the ones who look like they're really keeping the bears in line. Now, after we have arced to Arcturus, don't stop there. Speed south to Spica. Spica is the blue-white star that is designating the wheat in the arms of Virgo, the maiden of the harvest. And she's known as the maiden of the harvest because farmers actually used to use her to know when it was time to harvest their crops. So when the wheat, or the star Spica, would go below the horizon, the farmers knew that harvest time was coming up, and soon they would need to get to work in harvesting their crops. Now, these four constellations that we talked about, Leo, Canis Venatici, Bootes the herdsman, and Virgo the maiden, they are all part of a springtime asterism. And so each season gets its own asterism or special shape. Spring actually has two, depending on who you talk to. So often in the United States, at least, you'll hear people talk about the spring diamond. Here in Germany, other parts of the United States, other parts of the world, France, we talk about the spring triangle. And you're seeing the spring triangle pop up here. So starting with Spica in the wheat, that's one part of the triangle. And then we go to Deneb in the tail of Leo the lion. And then we go to the knee of Bootes, Arcturus. And if you wanted to make that the diamond instead, you would just go to the brightest star in the collar of Canis Venatici, Cor Caroli, and that would turn it into the spring diamond instead. Now, summer is approaching. We hit the summer solstice on Saturday, June 20th. And so just to give you a little sneak peek, since we are heading into our summertime sky, we are going to take a look at Hercules, or Heracles. And Hercules, of course, is well known for being a demigod, son of Zeus, and being extremely strong. He is often able to be identified in the sky because the 6 brightest stars kind of look like they're making a bow tie shape. Bow ties are cool. And the top part of the bow tie is known as the keystone asterism. So that's another way that you can find Hercules. And the keystone asterism is also where you can find the Hercules globular cluster if you happen to have strong binoculars or a telescope. So-called globular cluster because it is a cluster of stars that have formed into kind of a globe-like shape. And next to Hercules, of course, you're seeing Corona Borealis, the northern crown. Below him, you're seeing Ophiuchus, the snake bearer. And then you're also getting an early glimpse at Lyra the harp, Cygnus the swan, and Aquila the eagle, along with one of my favorites, Vulpecula the fox. But one of the cool things about this system that we have here is that we don't have to be bound to Earth. We can actually leave Earth behind and fly out to space. And so leaving Earth behind and floating now out beyond and looking back at our planet, we're not going to stay here too long. We're going to go ahead and explore. And one of the first things that we're going to do is explore the first off-world body in space that humans have ever visited. And in fact, at this point in time, the only, and that is the moon. So we are going to travel quite a distance. Now, it took the Apollo astronauts a few days to get there. We are going to be able to travel these 384,000 kilometers, or 238,000 miles, to the moon in just a matter of seconds. That's about 30 Earth diameters to get there. To try and put that a little more into perspective. And as we come up on our moon here, we are coming up from the side that's receiving, or that's in shadow right now. Now, oftentimes, we hear about the dark side of the moon. Pink Floyd wrote a song about it. There really isn't a dark side of the moon. All sides of the moon do get sun at some point. It's just because Earth and moon are tidally locked to each other, we only see one side of the moon. So really, there's a near side and a far side. So as we move now to the side that's receiving the light, we can see quite a few craters. The moon has taken quite a beating over its lifetime. And at this point, we see all these craters and how pockmarked it is. it's good to point out that the Apollo astronauts, when they landed often near the equator of the moon, and all of these landings happened somewhat in the same area due to the terrain. They needed a safe place, but they also wanted to visit varied spots to try and collect as much data as possible from the few missions that actually went and landed on the moon. But the moon is just the first stepping stone that we have achieved in space, and going back to the moon, we're very excited about that, but we're also looking onto what comes after the moon. And of course, that would be our neighboring planet in space, Mars, the red planet. So we are going to continue to fly past the moon out to Mars. Mars is very similar to Earth in some ways, and also, of course, very different. Mars is a little more than half the size of Earth, but its day is almost exactly the same length. A day on Mars is only 30 minutes longer about than here on the Earth, so 24 and a half hours. But its year is about twice as long as the Earth's. Now, Mars has 2 captured asteroids from moons, Phobos and Deimos. So Mars was the Roman god of war. Phobos and Deimos were Mars's sons, Fear and Panic. So, striking planets and striking moons. Now, while humans have never been to Mars, we have been able to send robots for ourselves. So whether those be the rovers, like Curiosity, which is still working on Mars right now, sending us data, or any of the landers, like ExoMars, or any of the orbiters as well, like the Mars Reconnaissance Orbiter. And it has been a joint venture. There's lots of different technology on Mars and orbiting Mars, not just from NASA in the United States, but also quite a bit as well from ESA, the European Space Agency. They have been sending quite a lot to Mars, and actually we've been getting some pretty cool data back from that as well. In fact, it was ESA's work that helped us discover that there is liquid water under the surface of Mars. So what we are looking at here, that long giant crater that you're seeing, that is Valles Marineris. And that is not only the biggest crater on Mars, but that is also the longest crater in the entire solar system. If you were to lay it out, for example, across the United States, and I do have to apologize because I come from the United States, that's where most of my examples come from. But if you were to lay it across the United States, it would stretch all the way from the West Coast in California to the East Coast in New York. So just to give you an idea, it's the entire width of North America. So that is quite a large canyon. And here we think the Grand Canyon's quite big, but it's got nothing on Valles Marineris or the Valley of the Mariners or the Sailors. Mars is also home to the largest volcano on Earth, and that is Olympus Mons, or Mount Olympus, so named after where the Greek gods and goddesses lived. And Mount Olympus, as I mentioned, is the largest volcano in the solar system. Now it's not erupting anymore. It is dead at this point, at least as far as we have seen in our lifetimes. And unfortunately, it seems that at this point in time, Valles Marineris is in the shadow. But we're still going to try and bring you in a little closer and see if we can't get that to give you at least a little glimpse at this very large volcano. And through the magic of the planetarium, we are able to bend the fabric of space-time and bring us forward to a little bit later in time so that we can take a closer look at Valles Marineris. Or excuse me, Olympus Mons. We already saw Valles Marineris. So we've taken a look now at Mars and our Earth, and we've hung around within the asteroid belt looking at inner rocky worlds. But I'd like to take you out further now to our gaseous worlds, and we're going to start by visiting the king of all the planets, Jupiter. Jupiter is the largest planet in the solar system and is named for the Roman king of the gods, Jupiter, which is equivalent to Zeus in Greek mythology. And Jupiter, until recently, was the king of all of the moons, but has been surpassed by Saturn now in the count. But we're always finding more because our technology gets better and better, and we're able to hone in on what is orbiting these planets. Another fun fact about Jupiter is that all of the moons of Jupiter are named after his girlfriends. And not that long ago, a piece of technology was sent to Jupiter named Juno. Juno is Jupiter's wife. So Juno went to take pictures of Jupiter and sent back really lovely images that have really helped us to understand Jupiter a little better and how it the weather functions on Jupiter. So even though it's a gas giant, it does have weather, and most people have heard of Jupiter's famous red spot. That is a very large storm that has been raging on Jupiter for as long as we've been able to study the planet up close, so about 400 years, and shows no sign of letting up anytime soon. So all these orbits that you're seeing right now, these are all Jupiter's moon's orbits. So once we fly through all of those moons, we can get to Jupiter itself. Now, one of the cool things is that you can observe some of the moons of Jupiter with just a simple beginner's telescope or even high-powered binoculars. You can observe what are known as the Galilean moons. So those are the 4 largest moons that Galileo Galilei discovered. And one in particular is pretty interesting as well. But before we jump to that, just to point out a few features here, the 3 swirls that you're seeing in the lower hemisphere of Jupiter, those are also storms. So the big red spot is not the only storm on Jupiter. There are many, many, many different storms. And we are actually looking at Jupiter upside down. If you look up a ways, there is a giant storm. That is our big red spot. And what I said was actually probably not the best way to put that. To us, it feels like we're looking at Jupiter upside down based on the pictures that we've seen, but there really is no up or down in space. So that's just based on our normal views from here on the Earth. Now, that moon I mentioned a moment ago, one of the Galilean moons, is Europa. And Europa is interesting because it is covered in ice, but underneath is liquid water. And we are actually wondering quite a bit if we have a possibility maybe to find life as we know it under the surface. And you're seeing all these scratch marks on the surface there in the ice. But overall, it is the smoothest planetary type body or celestial body in the solar system. So even though it looks quite a bit like it has valleys and canyons, it's quite smooth. So this is a moon that we are wanting to study more. And we've gotten a chance to look at it further thanks to several probes and orbiters that we've sent over the years. Now, I can't talk about Saturn, or excuse me, I can't talk about Jupiter and not talk about Saturn. I'm so excited to get to Saturn, I've completely already forgotten Jupiter. So we're gonna fly to Saturn now. And Saturn is, of course, thought of as our ringed planet. Now, that's easy to think of Saturn that way because the rings are very, very obvious. They're quite large, beautiful to look at. It is not the only planet in the solar system, however, that has rings. All of our gas giant planets have them. So Jupiter, Saturn, Uranus, and Neptune all have rings. Saturn's are just the biggest, brightest, and easiest to see with simple backyard telescopes. Those are made of ice and rock and particles that Saturn has trapped into orbit around itself. Now, Saturn is the reigning king of moons, and all of Saturn's moons are named after characters from Shakespearean works. Or excuse me, that's not true. That is Neptune. Uranus, excuse me. Just talk about all of the gas giants. So Saturn, some of the moons actually orbit, or one of the moons in particular, orbits inside of the ring system. So the gap that you're seeing there in the rings between the outer edge and working the way in, that is actually caused by a moon orbiting within that path. Now, Saturn is also prone to very violent storms. And every once in a while, we're treated to a beautiful image of storms, particularly among the poles of Saturn. Now, I am unfortunately going to skip over Uranus and Neptune because I want to get to everybody's favorite dwarf planet. And that, of course, is Pluto. And as we're flying to Pluto, I know that there's some of you out there who are watching this thinking, but Pluto's still a planet. I want it to be a planet in my heart. And I know that most of us grew up with it being a planet, and we all feel that way somewhat, but it's worth pointing out that Pluto was not demoted. A lot of people say that. Pluto was just reclassified. It's better understood now. So it's actually a good thing that Pluto was reclassified as a dwarf planet. And of course, we had New Horizons fly by a few years ago now, giving us our first really good close-up views of Pluto. Before that, the best we had was from Hubble. But those images from New Horizons were what really helped us see and understand Pluto a little better. And it is indeed an icy body. It has 5 moons, all having to do with the god of the underworld. So Pluto was the god of the underworld in Roman mythology. And its largest moon is Charon, and they are very tightly bound together. And in fact, their bury point, their point of equilibrium is not within Pluto itself, as one would find many times with the planet, but rather lies in between them. So, and there's the top of the famous heart that everybody knows and loves from Pluto. So Pluto showing you all a little bit of love right now. So we've reached the end of the planetary part of the solar system that we think of often. But there's much more, much, much more. And we don't even have to stay bound to our solar system here in the planetarium. We can go even further. So we're going to now leave our solar system behind. And there are other dwarf planets out there beyond Pluto. All of them are referred to as trans-Neptunian objects, trans-Neptunian objects, and they are all just out there in that area beyond Neptune. So right now there are 5 dwarf planets that are officially recognized, but we think that there are actually thousands more out in that area, in the TNO area beyond Neptune. So saying goodbye to our solar system as we fly out further and further. It's going to get a little bright. And now we've lost our solar system, just pinpoint of light amongst other pinpoints of light. Now, something to keep in mind as we continue to fly out of the Milky Way, our home galaxy, is that every star that you are able to see in our night sky it is a part of our Milky Way galaxy. So we don't see other stars from other galaxies from our own night sky. Those are all part of our home galaxy. And the Milky Way is a spiral galaxy. Here we see it floating, or seemingly floating out in the universe. The Milky Way is part of the local group. The local group is a cluster of galaxies, part of the Virgo cluster. As we zoom even further out, the Milky Way begins to look quite tiny, but don't be deceived. The Milky Way is a little over 100,000 light years across. So to put that in perspective, of course, a light year is how far light travels in 1 year. So if you could go at the speed of light, it would still take you over 100,000 years to travel from one side of the Milky Way to another. So at this point, all of the specks of light that you're seeing, those are no longer stars. Those are other galaxies. So we are looking at all of the galaxies that we have discovered in the universe. And as we continue to zoom out, you're going to see more and more of that. And we can actually fly to the edge of the known universe and see what is sometimes known as the butterfly effect. And you may be wondering why it has this shape. Simply, it's because that's where we've had the funding to do the research to find all of these objects. We haven't been able to study the areas that are missing just yet. So that's something to look forward to in the future as hopefully more funding becomes available to discover what else is out there in our universe. But we don't want to leave you hanging at the edge of the universe. So we are going to fly back now to our home planet, the only planet that we know of capable of sustaining human life. And flying back through some other galaxies, heading back to our solar system and what we know as home. And that bright light becomes familiar in that spiral pattern that we know. And as we fly into one of the Milky Way's arms, we'll start to recognize more and more. Flying amongst stars that we can see from our home planet. And seeing some other galaxies that we can actually see from our own solar system as well, from our own planet. There are galaxies that can be seen with the unaided eye. Two of them are located in the southern hemisphere, the Large and Small Magellanic Clouds, which we did get a quick glimpse of. Another is from the northern hemisphere, that's the Andromeda Galaxy, but that is best viewed in the fall time sky. So you'll have to stay tuned for fall time to hear more about that one. And as we fly back to Earth and slowly fly past our moon, we're going to take a moment and pause outside the Earth in Earth orbit. And we're going to visit the International Space Station. So the International Space Station orbits the Earth at about 17,500 miles an hour. That's what keeps it in orbit. That's how fast it has to go to stay in orbit around the Earth so that the Earth's gravity does not pull it back in and have it re-enter. And as many of you probably know, we were hoping to be able to see a capsule docking with the International Space Station today, and that would be the first ever crewed Dragon capsule from SpaceX. But unfortunately, that launch got scrubbed yesterday. That would be the first launch since July of 2011 from Cape Canaveral in Florida in the United States. Right now, all launches occur, or at least up until SpaceX does this launch, all launches occur from the Roscosmos site in Russia. And so all astronauts on board the International Space Station at this point did launch from there. And so right now there's 3 astronauts aboard, 2 Russians and an American. And now you're seeing the Dragon capsule that will eventually dock with the International Space Station. So 2 astronauts will take it up for its first flight with humans aboard. It has flown an uncrewed mission previously that went quite well. So the next launch attempt is going to be Saturday evening for us here in Germany. Definitely something you're going to want to keep an eye on. It's going to be an absolutely spectacular launch. Something to really look forward to. An interesting thing to note, the astronauts that are flying, Doug Hurley was on the very last space shuttle mission, and now he is getting to fly the very first flight to leave from American soil again. So that's an exciting and interesting thing for him to be able to do. And he's actually flying with one of his best friends, Bob Behnken. The 2 of them entered through the same astronaut class, which makes them ideal partners to be able to fly this mission. And just to give you an idea of how tiny that capsule is compared to our Earth, there we are. And looking at that beautiful blue planet, we see what we know as home. And from up here, we see no borders, no strife, no worries. We just see this beautiful blue marble in space. Absolutely gorgeous to behold, something that we need to take care of because it's very precious. We need to take care of it, and we need to take care of each other. And unfortunately, that is all the time that I am going to get to have with you today. So I'd like to leave you looking at this beautiful image of the Earth. And would like to thank you for joining me on this flight through the universe today. I hope that you enjoyed it. I had a lot of fun with you. Thank you so much for inviting me into your homes this evening. It was a lot of fun, and this is something that we do every week here from the Zeiss Planetarium. So we do live streams every single week. Normally they're in German, but we also have music programs and lots of other really interesting, cool programming for all ages. It varies from week to week, so you are always bound to find something that interests you in our live streams. So we hope you'll join us again. You can check out everything on our YouTube channel. So we hope you'll join us there, and also like us on social media, Facebook, Instagram, and we hope to see you again next week and the weeks that follow as we continue to be welcomed into your homes. So thank you very much.